Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smartyurl.it/Jedi. My advice on how to pass actuarial exams is at smartyurl.it/pass. This video channel is at smartyurl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smartyurl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smartyurl.it/help-ISU actuary. Here's a problem for today for exam LTAM, long-term actuarial models. A mortality improvement model similar to MP 2014 uses an age-based cubic spline to interpolate between the base mortality rates at time t equal to 0 and the long-term rates applying from t equal to 3. You are given the mortality improvement factors and their derivatives at the two endpoints. Phi of 40, 0 is 0.035 and 5 prime of 40, 0 is 0.00. So 0 really. Phi of 43 is 0.005 and 5 prime of 43 is 0. Calculate the value of the spline for age 40 at t equal to 2. Recall that in general a spline is a special function defined piecewise by polynomials, and a cubic spline would use a third-degree polynomial. We are using a cubic spline in this problem. And then the question that you might have is, well, where does it fit? How many points and so on? So if you had a cubic function, well, if you have any polynomial function, this is what it's supposed to do, fit the points. And then, as this picture is trying to show, in this case, the function, the spline is the values of it are on the vertical axis, and t is the horizontal axis. And we want a fit like what you see here, but if we can't get it, then we fit individual cubic functions at various points and then connect them at points where they fit. So you would, for example, take a cubic function going through these 3 points. That would be unique because a third-degree polynomial would be defined by that, and then you could fit another one to this piece here, and then combine the two. That would be what cubic spline does. So what does this mean for this problem? It's really not kind of uniquely defined. You need to carefully guess the intent of the people who wrote the question, unfortunately. And what we're basically saying is that, well, let's try a cubic function and see if we can fit it to the data. Because if we do, then that's our cubic spline. And if we can't, well, then we'll figure it out later. So we'll just start with a cubic function of this form. C of 40t, which is phi at xt, but with x equal to 40, so that x here should be really 40, is of the form at cubed plus bt squared plus ct plus d. Then the derivative with respect to t of that expression is 3at squared plus 2bt plus c. And we note that C of 40, 0 is D. Well, that's phi of 40, 0, and that's given as 0.035. And then the derivative of C at 40, 0, which is phi prime of 40, 0 as well, that's given as 0, but that's equal to C, because that's the value of C prime of 40t when t is 0. So we actually immediately see that C is 0 and D is equal to 0.035. And then C of 40, 3 is 27A plus 9B plus C3 plus D. So 27A plus 9B plus 0.035, because 3C is 0. And that's equal to phi of 43, which is given as 0.005. So that 27A plus 9B is negative 0.03. Also, C prime of 40, 3 is 27A plus 6B from the formula for C prime that we derived above. And that's phi prime of 43, and that's given as 0. We have this system of equation as a result. 27A plus 9B is equal to negative 0.03, and 27A plus 6B is equal to 0. Subtracting the second equation from first, we get 3b is negative 0.03, so that b is equal to negative 0.01. Well, based on this, a would be equal to 0.06 over 27. Divide the top and bottom by 3. That's 0.02 over 9. That's approximately 0.002222. We're looking for c of 40, 2, which is phi of 40, 2, and that equals c of 42 by the formula that we assumed for this spline to be a times 2 cubed plus b times 2 squared plus c times 2 plus d. So 0.02 over 9 times 8 minus 0.01 times 4 plus 0 plus 0.035. That's approximately 0.012777778. That's answer C. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.